Okay, so I'm going to look at this review, and let's see if we can do anything with it. Not sure how this is going to work, so hang on a minute. Okay, so it says a dryer runs for 10 hours during 1 week of operation. The dryer has a power rating of 500 watts, so number one. The power is 0.500 kilowatts. So the energy is 0.500 kilowatts times 10 hours. Or every week I use 5 kilowatt hours of energy. Okay, so that's A. How much does it use during 1 week? They want it in kilowatt hours, and then they want me to put it in joules. Well, there's 3.6 times 10 to the 6th joules for every kilowatt hour. How do I know? Got on the internet, looked up the conversion, and I have 5 of those. So that means I'm using up 1.7 times 10 to the, let me see, 10 to, actually 1.8 times 10 to the 7th. Yeah, honey? Yeah, it's laying there by your chair. Sorry about that. Okay, so 1.7 times 10 to the 7th joules. And if you needed that conversion, of course, I would give it to you. So there's number 1A. Then it says Part B. There are 4 weeks in a month. How much does it take money-wise to operate for a month? Well, I have to burn up 5 kilowatt hours per week. There are 4 hours in my 4 weeks in my month. And they're going to charge me 8.2 cents or $0.082 per kilowatt hour. So when I do that math, I wind up figuring out that it costs me $1.64 per month to run my dryer. And then they want to know how much is it going to cost to run my dryer for a year. Well, I have 5 kilowatt hours per week. There are 52 of those in a year. And there is going to be a charge from my electrical company to pay $0.082 per kilowatt hour. So if I do all that multiplication, I wind up figuring out that to run my dryer for 1 whole year is $21.32. So there is A, B, and C for number 1. Okay? So now I'm going to get rid of that, and I'm going to talk about number 2. So if I'm going to talk about number 2, there's number 2. And what it's asking me to do, it's asking me to find the equivalent resistance for each of those circuits. So this right here is really 1 over 5 plus 1 over 10. So 1 over 5 is 2 tenths, plus 1/10 is 3 tenths. So RT for that is 3 1/3 equals 3 1/3 ohms. So for the whole circuit, I have a 10, a 3 1/3, and a 15. So if I add all that, I get 28 1/3 ohms. Because that's 25 and 3 more is 28 1/3. Okay, then I look at this one. These are in parallel, so I say 1 over 30 plus 1 over 6. So 1/30 plus 5/30 is 6/30. 6/30 is equal to 1 over RT. So if I flip that over, RT is 5. So now if I redraw that, I have 100, a 5, and a 50. So if I do that math, 100 plus 5 is 105, 50 more gives me a total resistance there of 155 ohms. A skill you definitely will need on the test. So I'm going to just get rid of that, minimize that, Actually, I'm going to come down and move my Word document in a little bit more. Okay, so now let's take a look at that. So number 3 says a current of 6 amps is maintained for 6 minutes. So hang on, I need to figure out how long I've been recording so we can figure out what we're going to do about the time. So let's see. Not there. So we've been on it for 5 minutes and 38 seconds. Okay, so we're good. Okay, let me get this out of the way, but keep it to where I can find it. Okay, so number 3 says, well, I have a current of 6 amps. Well, 6 amps is 6 coulombs every second. I'm going to run that for 3 minutes. 3 minutes is 180 seconds. So if I multiply 180 by 6, I get 1,080 coulombs. So that's how much charge it is. Then they want me to convert that to electrons. Well, you have to think back when we first started several units ago that 1 electron is 1.6 times 10 to the negative 19th coulombs. So if I divide 1080 by 1.6 times 10 to the minus 19th coulombs, I wind up figuring out that I get 6.75 times 10 to the 21 electrons. Not quite a mole, but we're getting there. Okay, so that takes care of number 3. Number 4 is a little more complicated, not hard, just have to do some thinking. Okay, if you look at number 4, well, first of all, I didn't give you any instructions. So what I want you to do is find Q1 through Q5, and then V1 through V5. Alright, well, let's see. This 3 and this 6 are in series, so I'm going to say 1 over 3 plus 1 over 6, which is 2 sixths plus 1 sixth, which is 3 sixths. And that's 1 over CT. So CT is 6 over 3, or 2 microfarads. Then this group, 1 over 2, 1 over 4, 1 over CT. So that gives me 1/2 is 2/4 plus 1/4. So that's 3/4, 1 over CT. So 4 over 3 microfarads is CT. So 4/3 microfarads is my total capacitance. Okay, well, let's redraw that. So that gives me a 2 and a 4/3 in parallel, and they're connected with this 30 down here. There's 90-volt battery there, 30 microfarads there. So that's my simplified diagram. This is my 2. This is my 1 1/3. So then I have to recognize that these little things, this group here, is really 3 1/3 microfarads. So now if I redraw that, and get rid of all this garbage over here, if I redraw that group and my original 30, then I have a series. So if I want to draw that, it's going to look like so this is my 3 1/3 here, and this is my 30, and there's my 90 volts. So I do 1 over 3 1/3 plus 1 over 30 equals 1 over CT. So when I solve for CT, I get 3 microfarads for all of that stuff. Okay, well, that's great, Miss Walker. Now what do I do? Well, Q2T equals CTVT. So I have 3 microfarads times 90 volts. So QT is 270 microcoulombs. So that means there's 270 microcoulombs here and here, because when you think about it, these are really in series, and in the series the charge is the same. Okay, so let's get rid of this and we'll do a little more work. Now I've taken my less complicated diagram, gotten rid of it, and I'm going to go back to my more complex. So the charge here and here I need to deal with. I know the voltage here, V1 plus V2, has to equal V3 plus V4, because this is in parallel with this here. So let's figure out the voltage on capacitor 5. V5 is equal to Q5 over C5. So 270 microcoulombs over 30 microfarads is 9 volts. So if I have 9 volts there, then 90 minus 9 is 81. Alright, well that's okay. That makes sense. Well, if that's true, then V1 plus V2 adds up to 81 volts, and V3 plus V4 adds up to 81 volts. Well, that's great, but you still haven't helped me figure out what's going on up here. Well, let's take a look. If this is 3 1/3 microfarads, and there's 81 volts there total, then I can use that to help me find the charge for this line. So let's get over here and deal with that fact. So the charge for 1 equals the charge for 2, because they're in series, is equal to the total capacitance for that line. Well, what is the total capacitance for that line? Well, I think that we wound up saying that 1 over 3 and 1 over 6 was 2, and the voltage was 81. So that's 162 microcoulombs. Well, Q3 and Q4 are equal. They were 4/3 microfarads, 81 volts. So if I did that correctly, that's 108 microcoulombs. So I know Q5 is 270. I know these two are 162. Each one is 162. This is 108. 108 plus 162 adds up to 270 for the whole group, which is a big old fat check mark. Now I haven't gotten V1. Well, V1 is Q1 over C1. And Q1 is 162. C1 is 3. The micros cancel. 162 divided by 3 is 54 volts. V2 is Q2 over C2. So I have 162 microcoulombs divided by 6 microfarads is 27 volts, and that adds up to my 81. Okay, that's good. Now let's check out Q3 and Q4. Or capacitor 3 and 4, I should say, because we would need V3 and V4. So V3 is Q3 over C3, 108 microcoulombs over 2 microfarads, 54 volts. V4, 108 microcoulombs over 4 microfarads is 27 volts. So I think I'm done. That makes me happy. Alright, let's get rid of that. Let's, I should have gotten the mouse there. Oops, didn't like that at all. Come back. There we go. So we need to deal with this one here. Change that diameter into a radius. Sorry, I didn't get a pen back. Okay, so the diameter is 5.9 centimeters, which is 0.059 meters. The radius is half of that, which is 0.02. Let's see, what did I get when I did that? 0.0295. So I'm going to stop and start a new one.